listeners of this podcast are certainly going to be familiar with the early exploits of DeFi Summer. Can you describe a couple of exploits that happened back then that would be solved by Supra oracles and how Supra oracles would solve that?
Certainly. So there's a couple of variety of different Oracle exploits. So let's talk about a basic one where a major DeFi protocol, they were getting their data from a major exchange. I don't need to mention the names. And they're getting, like, for example, the price of Bitcoin.
Oh, that's no fun.
I know. Well, one of these exchanges are actually investing in us, so I don't want to throw shade at them. But very reputable organization. And it was just, of course, This is a very early period for just the industry at large. So, everyone was experimenting. But their model was, and the DeFi protocol was getting the data from this exchange directly, relying on the fact that that exchange would cryptographically sign the information. And they thought that was enough, both the developers and the researchers on the DeFi side. And the exchange was just opening up the service. Now, the thing is, just because someone has cryptographically signed, for example, the price of Bitcoin, that actually doesn't mean that it is the correct price of Bitcoin. It just means that someone had access to the private key. And what happened was someone or something was signing incorrect data. So incorrect data got into a smart contract. That smart contract executed it, and it caused some problems. So this is an instance where it's a singular source of information, very reputable, nonetheless, a single point of failure, and someone somehow got access to the key and signed incorrect data, and that entered a blockchain. That's one instance. There's other instances where, and I don't want to mention Oracle names or project names either, but where, like, a small cluster of nodes from a very reputable or well-known Oracle, a small cluster of nodes, they had signed off of information, and a DeFi project was getting that information from that Oracle, but they had screwed up their results. Basically, they had reported the wrong information, and they didn't have any repercussions. They didn't have any recourse or any remuneration at all. It was just like, oh, sorry, my bad. Shit happens. And it's like, really? There's really, what I'm saying is, like, if you have your securities bound to a small set of nodes that are not staked, that are not, they don't have this, like, economic possibility of penalty, and their identities are not necessarily known, then it's very easy for them to be a little bit careless about their reporting. So in that case, your network security is bound to a small set of nodes. Now, another major kind of Oracle and bridge exploit that's become kind of common is this idea of flash loans. So now that is using on-chain data to protocols that were using on-chain data to use what's called a constant function market maker. So, like, X times Y equals K. It's formula, which is an algorithmic estimation of what is the price of X, Y, and Z. Those types of systems rely on arbitragers to get back to an equilibrium. And what was happening is, like on Ethereum in particular, with this, the ability for smart contracts to compose with each other or interact with each other, very clever developers were able to borrow large amounts of money in a single transaction, lend against or borrow against this, adjust the kind of ratio of the price differential, and then pay it all back in one transaction, and then cause some very severe changes in the reported price. That kind of situation has caused some major loss in value. And then, of course, there's also the final version of exploits, which is where actually the node providers or the nodes themselves are front running the results. They're basically reading the results before they post it and sign off on it, trade against that before they post it, and then also just other vulnerabilities in terms of smart contract bugs.